Hello and welcome to this Tekla webinar on reinforced concrete. We're going to go through the basics of Tekla rebar modeling, basically how it works and how you can take third-party information into the model to start with. So yeah, we're going to start with the importing models and also DWG information as well. We're going to show how you can use Bim Site to share your data-rich 3D model with the contractor and with the architect and engineer to collaborate on the project. We're going to show how easy it is to model reinforcement within Tekla. We're going to produce automatic drawings and scheduling, and especially scheduling that goes direct to machinery through the BVBS export. So like we're providing the same services as the structural steel industry had. We're now providing those to the concrete industry as well, and all the benefits of that CNC data as opposed to somebody typing in manual. So for accuracy, things like that, that's now available to the concrete market. Questions and answers. You can email any questions to myself, Paul at walker@tekla.com. And if you want, a more in-depth demo at your offices, also email me and I'll call you and we can discuss your needs. If you're going to have to nip out before this webinar over, it is going to be about 45 minutes rather than half an hour because there's quite a lot to fit in. You can watch it later on at tekla.com /UK under the highlights. You can see there it's got Tekla UK webinars, and please feel free to forward it on to anyone that you think may benefit from this webinar. I must just apologise, it is actually pre-recorded because I've had to go to London this week. But I've just recorded myself live, so really there's no difference, and you can tell that from my umming and ahhing at certain points. So I'm going to let it play through. Like I say, get in touch with myself for any questions, and then we look forward to hopefully getting some of you guys who are not on board yet on board with the 3D detailing. So enjoy the webinar. Okay, so what we're going to do here is object converter from a Revit model. So we're going to take a Revit IFC model that's been exported by Arup using the Tekla to Revit conversion, which is available from the Autodesk website or the Tekla website, all part of the Open BIM. So this is the Tekla model. Basically, just like in AutoCAD or something, we have an XREF concept, if you like, where you can insert a reference model. That reference model can be a 2D CAD, an IFC zip like this, or it can be a Bentley DGN. We insert a lot of different file types as reference files, and they are effectively just a reference, so they're not going to make the model heavy or anything. So if we take that one and we can apply an OK, and then we can insert it into the model. I've already put one in just to save time on this webinar. It took about 2.5 minutes to load in. So now if I go to my reference model list, I can see here again it's just a list of reference models that you could have in here. They could be 2D and 3D, but if we just show this to visible now, you'll see that that's a structural IFC. The engineer on this project has used Revit. It could be the architect's IFC that then you would be bringing forward to structural levels of detail, so upsizing columns, etc. But in this case, and in a lot of cases, it will be a Revit structural model that just needs reinforcing. So if we start to look at the IFC, you can see here that if we pick one of the parts and inquire, you can see you get a lot of information that comes through, and that's the whole point about the information in BIM, is the information contained in this model. So we can see there column diameters, where it's come from, even who's modelled it, hi Joe, and we can see what it's made out of as well. That's a precast column, and even the grade of concrete, C60. So there's a lot of information in these models already that we can use in the project. The IFC conversion itself has really has come on leaps and bounds now. If we just do it to show just a minute, this piece of the slab here, for example, you see it's quite a complex geometry and has got a lot of cuts in it. However, if we open the IFC converter, I can pick this slab and I can say convert. And what that'll do is go through and actually convert the IFC object into a Tekla object. So it's pretty cool how it creates all the relevant cuts to create that. So I can redraw. Let's just hide that. So I can hide the reference object and just show the Tekla piece now. So this is now a Tekla object. So we can go in there and we can map a concrete grade to it. So you can say it's C30 if it is. If it's just for the rebar, you don't need to bother doing this. And we can also give it a type, so cast in place, and the prefix. Could be slab, for example. So it will get an actual reference on a drawing or in a schedule. And redraw the view, and again go back to this model. You can also bulk edit. If I go and let's just pick the car. So just going to get the concrete car, which is effectively the cast in place part on this. We've got foundations as well, but we'll just focus on the car for now. Let's hide the Tekla and the slab we've already converted. This is quite a good feature, really, that most things will convert, slabs and walls, but occasionally you get things that won't convert. So you can see that Tekla's highlighted these objects in a slightly different color, and you can see that the reason it's not going to be able to convert them is we've just got a bit of I don't know, complicated geometry here where it's cut through at a surface point. So Tekla knows it's not going to convert them. So a couple of things we can do. We could just hide these objects and not convert them. So if we just put a cut plane on there, we'll pick these ones that we know aren't going to convert because of the colouring and the lines. Hide those. Open up the cut plane. And I'm going to do this and let this run live just to sort of to get across how important this IFC conversion is. If you're using another 3D rebar software and you have to remodel the engineer's model or the architect's model, not only are you taking on the responsibility then, making sure you've got your concrete modeled the same as they have, but you're also losing that time. And to model up a 12-story building like this is going to really affect your cost for detailing. There's no way that you can be competitive if you're going to have to remodel all your concrete every time with somebody who's using Tekla who doesn't. So we can pick this. Let's just go for all these concrete walls. For example, we'll just take the walls for now. And I'm going to run this conversion again, just on all these walls. Now this conversion will take, I'm guessing, maybe about 4 or 5 minutes. But again, compared to having to remodel that and again taking the responsibility for that, it's a real bonus. So while that's on, I'm going to show the Bim side of Tekla, which is our free software, and really makes this 3D model and the rebar model available to the contractor, to the project team, to the design team, to all collaborate on. And again, there's no cost for this, so it makes the BIM available to everybody, if you like. So if I open this up, this is a BRC reinforcement model. BRC reinforcement are one of our customers, and they've been using Tekla to create some very interesting projects. So this is a concept model that they've done for some offshore work, and you can see the detail of the model, and this has all been modeled digitally. And especially when you get into this kind of stuff, Tekla really sort of shines through, and we'll let you produce these highly detailed models at low file sizes for coordination. I mean, and this really is the benefit. It's the communication of information between project parties. You know, if a drawing or a picture says 1,000 words, you know, an information model can actually tell you everything about this. So these aren't just pretty pictures. If you go onto a bar, you can actually get all the properties of that bar. So its length, its bar mark, its location. So it's the near face 1. It's 25 mil bar. It's a shape code 67. And as much or as little information can be taken through. In terms of actually coordinating, if you are a detail and you're sending to the engineers for checking, you can actually send this model off, and the engineer can add comments. So if he wants to add a comment to this bar, for example, I can add a note directly to it, and I can say increase to a 30 or something like that, and save, and then I can actually share this as an RFI email. So if I can just send this to myself for now, and it basically creates this little BCF zip format, which is the BIM format for sending information, and I can send that off. And if I sent that to a member of the project party, they can open that email up, grab that, and it will open up Bim Site, and it will go to this view, it will select this bar, and it's a totally clear way of communicating information. Also very helpful if you lose a bar on site, you can actually pick that bar and let the fabricators know. The other great thing about Bim Site is the ability to do these animations of the constructability of a project. I mean, again, BRC have put this together to show, you know, again, this is all about prefab and getting things installed quickly on site. And again, there's no way you can do this with traditional detailing. This is what BIM's all about. This is about speeding up construction on site. And planning. Planning is everything, and the 3D model allows you to do that planning, and that's what it's all about. So you can take a project like this. I've speeded this up a lot, but it's not just a pretty picture. It's a stop animation. But if you stop it at any point, you can just stop the video, if you want to call it a video, and just have a look at how these details are actually going together. And again, you can inquire on the bars, and it'll tell you what these bars are, how they're installing. If you're happy, you can just carry on playing, and it'll still play through. So you can see exactly what's coming here. Effectively, if you've got this and it's prefab, you don't need drawings on site. All these cages have got references, and you can just track the cages in. You can list out the order of the cages delivered to site, have it all pre-planned, turn up, bosh, installed, and built up. So that'll just play through, show how the concrete's going to go in, show how the pours are going to go in. Again, this is all about communicating information and the ability to communicate that because you've got this BIM model. We'll come out of there. So you can see when I mentioned the cages there, you can see that you can show all, or if you want to look at individual cages or carpet rolls, you've got some little tools in here that'll let you so that'll show you that carpet roll. So you know that's a B1 carpet reference 1C. So when that turns up and it's got a tag on it saying 1C, you can just pick it here and see where that should go in the model. So again, it's all about communication, and it's all about speeding up construction. So we'll come back into the model now. That's nicely converted. So you can see there, you could just check some emails or something. And then when you come back, there you go, all converted nicely into Tekla objects. So you can see it's not deleted the original, we can still see the original. If we go back to there, and I can just ghost the original, and you can see that conversion there is spot on for all those complex geometries, even with all the cuts around the door openings and the holes in the actual concrete itself. So you can go around and basically just convert what you need from Tekla. The only other real consideration is how you're going to reinforce that. So let's turn off our reference model a minute. It's just a report. Reference model list. Let's hide that. So some things to consider are sort of constructability issues and making sure things are the same. So I just noticed last time I converted on here. These walls have been modelled as well, you can see that these walls come all the way through, and this is a short wall, and here we've got this wall is a long wall, and this wall runs all the way through. So we can, if we really, in terms of numbering and counting and things, we really want things modeled the same, so you get the same amount of bars and things. So we can just use Tekla's dynamic modeling to just quickly swap these round like that. These are the new modify tools, which just make modeling rapid. And then the next thing you've got to really think about is what do you want to appear on a drawing, the drawings that are going to be the rebar drawings. So the next stage is to bring it together in the form for drawings. So we don't want panel drawings of just one panel. We're going to want a drawing of this entire wall probably, and then one of this wall down here and the other. So what we have in Tekla is a cast unit system. So I can pick the main walls, like this, and then what I can do is cast unit. I can create a cast unit. Oh, apologies. These have come through as precast, but we can bulk change. I can pick all these. I can just switch on. I can use the match properties to just change the properties I like. So I just want to change them to cast in place, modify, and that's them all changed now. So then I can do it again. I can just pick panels that I want. If I accidentally pick something, I can just deselect it. Middle button, cast unit, create a cast unit. Now if I pick with the cast unit selector, I can see that that is now that cast unit. So any rebars that I associate to that wall will be scheduled as wall A or whichever prefix we define. We can do the same for this wall. So we can take this and, apologies, pick something we can't pick there. I just picked a cut accidentally, so cast unit, create cast unit, and again, so then we'll be able to have a nice elevation on this wall showing all the reinforcement, a nice elevation on this wall, and we just go through, and it's all about just grouping into which parts of the reinforcement you want. I'm just going to show, the columns are precast, but I'm just going to show how that would convert just for any of our people watching who are precast users. It's a similar process, and it's also going to highlight the importance of the information within an IFC model. So if I turn on my reference model again, and I can see my reference model. And just to make things easier, I'll turn off all the Tekla parts. I'll do it the other way around, and just have on only reference objects. So now I'm back. So you can do it both ways. You can show just either or. So now I'm back to the reference model. I'll show it full, and we'll move on to the columns. Show how we convert a column for reinforcement. For precast, it's pretty straightforward. You can just pick a column, and if we inquire on it, again we can see this is what I was talking about when we're about the quality of the information within, or the reliability of information within IFCs. So you can see here that everything about this column is at first glance is kind of telling me that it's a 450 column. We've got element type 450, we've got profile type 450. Its name is a object type is a 450, but actually in the model, and again precast 450, but in the model it's actually 530, and you can see here if we go to dimension diameter, it is actually the main stem of the column, not the external bits. The main stem is actually 530 diameter. Now this makes it a bit difficult for Tekla to map a profile, because using the again, if I open the IFC converter, what I'm going to struggle to do is map that profile, because we can actually, you can check so if I do a check on this particular part, it'll produce me a little and then you can see that the profile name it's trying to map is a 450. So I could map that to a 450, to a 530, but the problem is there's other diameters that are 570, 600 that are still called 450s, so I can't use the profile mapping. However, there are tips and tricks that we can do to get over this. What I've created is filters. It's pretty cool. You can filter on external information. So there, for my 530 columns, I've created one that's just external dot. So any reference object is external dot, and then you can just simply pick the property. So height, any of these you can just pick and then match the properties in there. So there I've just said any external dimensions that are 530. It's good enough selection for this. We can say apply and OK. And now if I window the model, it's only going to pick things that have a dimension of 530. Just the one. Something not right there. Just 1 second. I think I have to subdivide the IFC into its constituent parts. Subdivide. What that does is breaks it down. Rather than being one big reference object, it takes it into the individual objects. I should have done that earlier. But now, if I do go on to my IFC columns 530 filter, then you can see it will pick all the 530 diameter columns. Now, because we can't map a profile, we'll just convert those, and it'll just convert them into a bounding box type conversion. So it'll just create one column for everyone. But you can see it brings them through there, so you can pick them in. You can go through and check individually if you want, based on the IDs. But all we're going to do is bulk convert these. So I can double click one if I go onto my standard filter. I can double click one of the objects. I can highlight them all, and then I can change them to a D530 and also map the material to concrete and C60s, I think it said on the IFC. I can modify those. Sorry, undo. I'll just undo that. Again, I use the match properties. So I only want to match the profile and the material. I don't want to change the heights of the columns. So if I modify, so they're bulk modify. So you can always get around things if the IFC information, and there's always enough information normally. You've just got to find it. So that's the columns converted. Redraw the view, and let's turn things back on in the display. Put the parts back on. So you can see that we're starting now to really build up the model that we can reinforce. And for the precast and the concrete. So that's IFC conversion and how you use the Revit information or the IFC information to then build up your panels that you're going to reinforce as a detailer. So I'm just going to leave that there, and now what I'm going to do is I'm going to open a model that I've started, and I've moved further on in the model and done some detailing and explain how that's done and show a bit of the detailing. So I'm just going to close this down. Okay, so I'm in the detailed model now that I brought on a little bit further. I actually modelled in the post tension as well, just because I don't think we've ever shown it in a webinar. You can actually model in all the strand, and you can model in the individual shear studs as well, or shear links if that's how it's been designed. And that's the sort of level of detail you can go into the model that allows for full coordination, quantity takeoff and clash checking that you just can't do with 1 to 50 modelling softwares. And that's throughout the entire building as well. So all the floors have got that level of detail in them. If we go back and just look at the elevation on grid line D that I've just done, sort of cut down a bit, and we select, if you remember I made the assembly of the wall to allow us to detail it. So just go to paint there. So I've just put like some basics reinforcement into the wall, just standard stuff. I'll just show you sort of how you go about modelling the reinforcement in with Tekla. It's pretty straightforward. If we just take panel, for example, let's take this one, and just keep the panel above as well. And we'll just show only selected on that. It gives us the two panels, and basically we can start to model in the rebar. So if it's straight bars, for example, verticals, and we do. If you pick any size bar, it'll automatically update the radiuses. So if you make these to 20s, you'll notice that the radius updates there. So you always get the right radius for the right size bar. We can control as covers here. So let's have 35 cover, and then the front plane's like the distance to the first bar and the last bar, basically. So you can take that. Let's have 50 starts. And the start and end are quite good because that's like the cover from the start and end of the bar, but you can also put negatives in. So like on the bottom, it's going to be 150 probably to miss the kicker. And then at the top, we can actually put a minus value in. So you can say like minus 850 and apply that. So then if we put some bars in now, you just pick sort of the bar itself, and then you pick the range of the bar, and that'll go in and put the bars in like so with the cover. And because the rebar is intelligent to the objects, you can actually copy that to another object. So you can pick the first one, pick the second one, and it'll put the same properties in. So even though this panel's longer, it's still continued, but then added the cover for this extra bar as well. To avoid clash detection, just forgot to do this. So in the group, you can define how you groups. If you use flexible last space, it always makes it very easy to avoid clashes, because you simply just increase the cover to the first bar. So you can say 75, and that one as well. Change it to the and you can save these as presets as well. So you get a nice clash-free model. So then obviously you just copy this one up every other one, and this one up every other one. So once you start actually putting some bars in, it gets really quick then to use those, because they can be copied parametrically. U-bars and things, you can basically control how far they span. So if we're putting a U-bar in, we normally call it a U-bar as well, so you can call that name off on a drawing. We'll pick some 16s. We'll keep the same cover. Now I need to increase the cover. And what we can also do here is we can say leg length and leg length. So this makes it really easy to just fire the bars in, because we can apply this, and then you can pick. So you pick again, just pick some concrete that you want to put the U-bars into, and then you just pick the general shape, and then arrange. So as little or as much as you want as a range, and what that'll do, those legs will always go in at that center, but the back leg will always be parametric because it's snapped to the concrete. So when you go through, build up your reinforcement, start to copy it around, and build up the model as you would. And it forces good detailing, because you have to think about how they're going to put this together on site. You can't avoid any tricky details. There's no like, oh, they'll sort this on site kind of attitude. You have to, it forces good detailing. And obviously, it's all going to fit when you get to site. So you can see the panel and panel drawing itself. So if I go to the drawing for this panel, and just take a minute to open. I mean, these drawings are the first one's sort of semi-automatic, and then once you've made your first drawing, you can do what they call cloning. So it'll take however you've made the first one, so you just do one wall basically, which is what I've done here. So it'll create those drawings, then you add the dimension marks. I've just created this one wall. So now, if you think when I made that assembly, those two back walls I made and all the panels I made into that what they call a cast unit. So that's how it knows to quantify and only show bars that are in that cast unit on this element panel, and you just get this sheet. Nice and simple, all call-offs, grid brought through as well. And then what you can do once you've made that drawing, make it easier if we go to this level. So I can pick these walls, and if I go back to my drawing list, I can actually pick this one and say create drawings, clone this, and then select these in the middle and say clone selected, and Tekla will run through and create these sheets automatically of the other walls. Take a minute, but it's better than drawing them. Better than all the scheduling information is also being produced now. Just give it a minute to pop up. We're creating 3 drawings at once here, so it's going to take a minute. But yeah, important to remember that it is producing them automatically. So once you've done the model, the drawings sort of take care of themselves. Okay, so it'll create us 3 drawings. And you see there, it's numbered the panels, so wall 1, wall 2, wall 3, and wall 4. So on a GA drawing, that's what you'd see, the wall 1, 2, 3, and 4. I'm going to concentrate on the RC drawings though. So basically you get a sheet of every window, of every wall. If we just open one of these clone drawings, even though the walls are a little bit different, they do actually clone quite well, and you also get extra notes on for the bars that aren't going to be ranges or might not be ranges. So you just come in and there's a little bit of tidying up to do. You can drag stuff, change stuff, pull stuff, just to get the drawing a bit more presentable, if you like. And then if you imagine those as like your viewports, and then in the drawing list, I can create what they call a multi-drawing. So I'll create this empty drawing, and you can choose a layout. So I'll just load in an A1 template. This one. Yeah, so I just load in an A1 drawing template. And then you can take the views that are only showing that reinforcement, and then you can stick those into one drawing. Now they'll just all stay synced now. So effectively the sheet drawings are there, and they're very handy for because you can put a title block on. So the individual drawings as well are really good for, I don't know, if you're doing prefab stuff. So if you're doing piles, cages, that sort of thing. Then you don't have to make these more traditional engineering drawings. You also got your individual fabrication drawings, if you like. So just give this a minute to pop them up. There's quite a lot of information on there, but again, you're not having to draw that information. The system's drawing it for you. And we'll just arrange these drawing views. So you can just pull them about like viewports. So you can have all 4 plan and elevation views on one drawing, and you can actually print. You can tidy these up if they need to fit on. Obviously, I've just rushed this through so we're not boring everybody on the webinar. You can also edit them in here as well, so if things have gone wrong, like this, but we didn't go through and tidy them up. So there is a little bit of tidying, but you know they're pretty automatic really. That'll create your drawings, so they're all called off. And if you have got more as well, this is quite a cool feature. So if we'd modelled all that, the other side's probably the same. So this would say 2 number wall 2, and that's the same as how the scheduling works as well. So Tekla's sort of like counting up all the similarities. So when you make these drawings, it tells you how many they are. We can also do section views and things in here. So you can just create a drawing view, section view. So at any point, you can just create a new section through that model, and then you can control what sort of information you want to see on there. So I can actually load in a section settings that will load in all my specific sections, and then again all your bar marks will come through. That. So this is the best bit. That, you know, you've done the model, so now all this is automated, and you can get sections through anywhere. This is calling off the number of the surrounding concrete. We don't want to show that. So it's once you've done the model, you know, the drawings take care of themselves really, and the scheduling takes care of itself. We did say we're going to go on to digital scheduling as well as the traditional scheduling. So if I close this drawing down now, and I go to, basically it really does look after itself. So if I pick this, as well as saying that you can create the traditional schedules from the model to British standard for the engineer to check, but what we can also do is export to a few sort of CNC type things, so BVBS export for bar bending machinery. If I actually come to this bar bending export, it's not a very good thing to demo because it's just automatic, but you see this reinforcement of selected cast units, so I've picked the cast units here. You can actually exclude reinforcement, so if there's certain reinforcement that you don't want to export, you can exclude it by a filter. You can take the drawing name, and then you can create a file for each cast unit, so effectively for all your wall ones you're going to get one file, and it might say make 10 of each of these bars. And some people can only accept 2D, some people can accept 3D reinforcement, and then spiral reinforcements from the piles. Depends which bit of software the fabricator's using. If we export that, it'll basically just create these text files, so 288 of 288 objects in 4 cast units exported successfully, so we know that it's alright, no errors. So then if we come into our model folder, it automatically creates a file for BVBS. They're the text files that the BVBS reads. They're pretty, you know, it's pretty straightforward. It's just length, bend, length, bend, length, bend, etc. And that's a standard format throughout Europe, pretty much, is the BVBS export. And effectively what it means is it's given us the same sort of security that the structural steel fabricators have, that they do the model, they export directly from that model. So instead of having somebody typing in from Excel sheets manually, where it's quite easy to just hit the wrong key and then it gets to site and it's the wrong size, we've totally negated that. And also because of this, it means that if the contractor's got the model, he can do his own call-offs from the model without having to go through hundreds of drawings. He can just pick certain bits and say, call me that off, or call me this off, and have it delivered to site, and even do 4D to that as well. So I mean, again, we've got to move on because we've got to show some bridges stuff as well. I know not much rebar modelling there, but again, if you want to see, you know, any more detail, you know, I'm more than happy to come down and go through, you know, into the more nuts and bolts of it and how you actually go through the project. But that's it. It's a logical process. It's get a model or build the model in Tekla, group your elements in, you know, just the logical order that you'd normally detail in. So walls, panels, lift pits, you know, just group it how you need to. Run the cast unit drawings. There's lots of standard drawings in there. So in this create drawing wizard, basically they're just standard templates to get you that, you know, somewhere near in terms of your first output, and then as a company you modify these to get your cloning template. I must stress that that cloning template will work on any job. It's not just this model specific. So if you, as a customer, you get these and you create a beam drawing, you get that bang on how you want, and then you save that as your beam template, and then you saw how quick it was to create drawings using those templates. So again, once you've got these set up, it's 80% automated, and then like a tiny little bit of adjustment just to get the drawings, make sure they're right, add a few sections, that kind of thing. So I'm going to leave that there for the time being for the rebar detailing. That's just how it works. Again, just to remind you that if you do want to know more, just drop me an email. I'll come down and see you. We'll go through it, make sure you're happy with it, and then hopefully can get some of you guys progressing onto 3D modeling of rebar